Hi, let us learn about polymorphism in object-oriented programming using Java. In object-oriented programming, or OOP, there are four main concepts: encapsulation, inheritance, abstraction, and polymorphism. In this video, we'll explore polymorphism, what it means, how it works, and why it's important in Java. What is polymorphism? Polymorphism is the process of representing one form in multiple forms. The word polymorphism comes from Greek. Poly means many, and morph means forms. In simple terms, polymorphism allows one object to take many forms. It means we can use the same method name, but it behaves differently for different objects. This is an example of polymorphism in real life. One person can take on different roles depending on the context, just like in programming, where the same object can behave differently depending on how it is used. Meet Ollie. At school, he behaves like a student. He listens to the teacher, takes notes, and follows school rules. On the bus, Ollie behaves like a passenger. He follows bus rules, pays attention to safety, and respects other passengers. At home, Ollie behaves like a son. He helps his family, spends time with them, and follows home routines. In Java, there are two main types of polymorphism: compile-time polymorphism, also called method overloading, and runtime polymorphism, also called method overriding. Static or compile-time polymorphism. Compile-time polymorphism, a class, can have more than one methods with same name, but with different number of arguments or different types of arguments, or both. Also known as method overloading. Let us see the example of static or compile-time polymorphism in Java. Here we have two definitions of the same method add. Which add method would be called is determined by the parameter list of the compile time. That is the reason this is also known as compile-time polymorphism. Dynamic or runtime polymorphism is a process in which a call to an overridden method. In this process, an overridden method is called through the reference variable of superclass. The determination of the method to be called is based on the object being referred to by the reference variable. Let us see the example of dynamic or runtime polymorphism in Java. There are two classes, ABC and XYZ. ABC is a parent class and XYZ is a child class. The child class is overriding the method myMethod of parent class. In this example, we have child class object assigned to the parent class reference. So in order to determine which method would be called, the type of the object will be determined at runtime. Now, we're going to explore the benefits of polymorphism in object-oriented programming. Let's see how it helps make our programs more flexible, reusable, and easier to maintain. The first benefit is reusability. Polymorphism allows us to write a method once and use it for many different objects. This means we don't have to write separate methods for every type of object, which saves time and reduces the amount of code we need to manage. It makes programming more efficient and organized. The second benefit is flexibility. With polymorphism, our programs can easily handle new objects without changing existing code. For example, if we add a new type of shape or vehicle, we can use the same method to interact with it. This flexibility allows our programs to grow and adapt without breaking anything. The third benefit is maintainability. Since polymorphism reduces code duplication, it also makes programs easier to maintain. When we need to update or fix a method, we only do it in one place, and all objects that use that method benefit automatically. This leads to fewer bugs and a simpler, more reliable code base.
Using Powtoon.